Ever wonder how humans get around once they've landed on the moon? Or how they collect samples of rock and dirt and search for water on planets that are millions of miles away? These are the tasks performed by rovers. In NASA's last 3 Apollo missions to the moon in 1971 and 1972, moon rovers were used by astronauts to roam the surface of the moon and travel as far as 22 miles across it. Also, there are currently 2 rovers on Mars called Spirit and Opportunity. These rovers study the planet's past and present climate and search for water. Now, here in Clemson, we have been tasked with creating a remote control rover ourselves, and we are going to show you how we did it.
Hi, we're Group 12. And I'm Kernan Guntenbein.
I'm Mitchell Moreland.
I'm Mac Davis.
And I'm Jeff Webster.
And this is how we designed our Lunar Rover. First, we broke down the main rover system into 5 separate subsystems. Each of one is a different person's responsibility. You start over here with electronics. That's Kernan. Drive system, that's Mitchell. Protection, that's also Mitchell. Chassis is Jeff. And excavation is me.
There were 3 steps in our design process. The first was conceptualization, where we came up with different ideas. The second was embodiment, where we worked towards designing those ideas so they'd fit together. The third was prototyping, where we would actually build the rover. This is the conceptualization phase.
So as previously mentioned, one of the subsystems is the electronics. The electronics kind of at the part where you figure out how you want to control the motors or the output of the vehicle. First, we had to figure out if we want to use Arduino or RC. I'm pretty sure everyone knows what an RC system is, which stands for remote control. That is what you have in your toy cars, which I can control with like those Bluetooth transmitters. Then second, we figure out if we want to do motor drives or electric speed controls. They're very similar in the fact that they transform current into like motor output. They slow down the current with resistors and turn it into an output of the motors. Then we have 2 different types of motors. We have geared and brushed motors. Gear would go better with the Arduino system, brush would go more with the RC system. Then the fourth part was the receiver. Here we had a Bluetooth receiver, which receives the information from like a transmitter, like the one from a remote control car or from a phone. Then the last part was the battery, which powers up the system. With different options like 9-volt batteries, or also like smaller, like 1.5-volt batteries in a pack.
So part of my job was design the drive and the protection for the rover. The rover would have to traverse a course with a lot of different terrain, including sand, rock, and dust. It would also have to be protected from dust and heat lamps. So a few of the ideas we had were having a tank-style drive system versus a car, like 4-wheel drive system with front-wheel steering, and then a motorcycle drive system with front-wheel steering, but only a single motor running the rear wheels. We also considered the use of knobby wheels that would sort of provide a little bit of extra traction. Traction was a #1 priority for us since we were going to have to get through a lot of different terrain. Another idea we had was 4-wheel drive versus free wheels at the front. Free wheels had the advantage of being able to rotate freely, but 4-wheel drive would provide a little bit of extra power. And then also heat and dust were 2 of the things we were trying to protect, but we also wanted to keep the rover light, so we had to decide of a lightweight way to protect against both.
So, for the chassis, we had to decide whether or not we would want to use 3D printing versus wood. 3D printing is where you heat up plastic and then you extrude it onto a platform, and it would print the part in layers. For wood, we would take raw pieces of wood and then we would cut them down, sand them, and then fasten the chassis together. For our design, we were considering either a strong or bare bones chassis. And for the strong, it would be heavier, but going across the actual course, it wouldn't have any sort of bending and it wouldn't break. Whereas the bare bones would be much lighter, it might be able to travel a little faster, but it would be susceptible to breaking or bending or getting caught on rocks.
So for the excavation subsystem, we had 3 different options. The first was an auger, like basically a garden auger that you would see in your backyard. It's got a corkscrew motion that turns and pulls the dirt out of the ground, and that would be used to excavate the dirt and then hold it until we get to the excavation bin and drop it in with a reverse. Next was a paddle wheel design like you would see on the back of a riverboat. It uses a continuous motion that spins that we would pick up the dirt with and then hold it within the chassis of the rover and then move to the bin and then complete the motion. Lastly, we had the track arm that would use 3 different joints, and it would basically have one elbow that would reach out, and then a second joint that would be able to scoop, and then a third joint that could rotate it from side to side.
This is the embodiment phase.
For the first one, Arduino versus RC, we decided to go with the Arduino board right here, so we don't need the RC anymore. For the Arduino, on the left, you can see, or the right, you can see where it connects to the computer, where you upload the code. Then you can also see where the output pins are that go to the motor drive, and also there's some power pins you can input the 9-volt battery. And second, we have the control of the motors. Here we have the motor drive, so we're going to erase the ESC. We didn't decide to go with that. So the motor drive, you have different pins. Some connect to the motors, they can connect the motors. Then you have the power input, and you also have the input from the Arduino. Then the third one are the motors. We decided to go with geared motors because the brushes were too expensive. The geared motors, we had to add gearing because the motors were too fast and didn't have enough torque, so we added this yellow gearbox. Then the Bluetooth receiver. We decided to go with this Bluetooth receiver. This one connected very well to Apple products and also to Android products.
So for the decision on tank versus car versus motorcycle drive, we decided we didn't like that motorcycle could have failed and ruined the whole Rover. We didn't like that the car was complicated, so we ended up going with a tank style drive system with skid steering. We did want knobby wheels, but we also wanted some traction, so we came up with that solution by putting some rubber on the outside of the wheels, and we also have little gaps between, so as you can see, they'll dig a little bit more into loose ground. Another decision we made, 4-wheel drive versus freewheels. We decided that 4-wheel drive was, again, unnecessarily complicated. We wanted front wheels to just spin freely. So the design we chose just had the front wheels spinning freely around the axle. And the final thing was heat and dust protection. The heat that we thought was going to be on the course wasn't as much as we thought, so we ended up just wrapping a little bit of electrical tape around the Rover, which also served as dust protection.
So our decision was that we were going to go with 3D printing. For a strong versus bare bones, we chose a strong design because we did not want to risk our Rover failing on the obstacle course. Here you can see that we have a very heavy, thick model, and it has standoffs on the top. Those are the little pins, and that's where the Arduino is going to be resting. You can see on the side that we have little holes for the motors to rest, and that's just to reduce space or reduce weight while maintaining the same size.
When we made our final decision, we chose to lose the auger system, and then we got rid of the track arm. We're left with the paddle wheel design. It has a bucket on it, and it rotates continuously 360 degrees and picks up the dirt, and then we'll drop it into the bin.
And now we're going to show you a quick demonstration of how we control the Rover with the cell phone app. This right here is a joystick to go forward, backwards, left and right, and the center button, and to turn on that you can control it with the leverage of your phone. And there we go!